Good morning, students. Am I audible to you? Are you able to hear me? Okay, thank you. So, in the last class, we have discussed about the moment distribution method. We have solved one numerical. So, is there anyone have any doubt about the last class? Okay, I think all of you have understood about that thing because you have already got that earlier in your third sem or fourth sem, that moment distribution method. So, I think it's familiar to you. So, once again, all of you please go through that and try to solve some other numerical, similar kind of numerical, whichever I have given to you. Okay, then today we will start one new topic. Okay, we will not stick in the moment distribution method for long because you have already got that in your earlier semester, so it will not difficult for you to understand this thing. So we will today learn a new topic, a new method that is called slope deflection method. Did you got this in your earlier semester also? Slope deflection method. Is it familiar to you? And anyone say, did you got this method earlier? Slope deflection method? Okay, fine. Uh, let's start this method. Let me share the screen. So, as you can see here, our next method is slope deflection method. We will discuss this method, okay? So, what is the slope deflection method? As you can see here, this method is ideally suited for analysis of continuous beam and rigid jointed frames. Using this method, basic unknowns are like slope and deflection of joints can be calculated. Moments at the ends of a member is first retained in terms of unknown slope and deflection of the end joints. Considering the joints, equilibrium condition is set of equation are formed and rotation of this simultaneous equation gives unknown slopes and deflection. Then end moments of individual moments are determined. Okay, so when we will discuss about what problem, then you will come to know how this method is working and what we need to do. Okay, so this is basically used for continuous beam and rigid jointed frames. For this method we need the slope and deflection also. So how we will going to find out this? So there are some assumption of this method. These are the best, very important assumption. So what is the first assumption? All joints are rigid. That is, the angle between any two members in a joint does not change even after deformation due to loading. As you can see in the figure, there is just a frame is showing ABC. At joint A in the figure, the angle between members AB and BC remains theta only even after deformation. As you can see here, First figure shows a rigid joint before deformation. If we allow deformation to the frame, as you can see in the next figure here, the angle between these two. Earlier, our frame is this. Okay, this frame is there. So due to deformation, the frame look like something this. Okay, but the angle between this frame and this frame remain same. That is theta. Okay. Next, distortions due to axial deformation are neglected as shown in the figure. As you can see, first our frame is A, B, and this C and D. This frame is there. If we give some pressure from this side, the beam may be distorted, something like this. Okay, make a deformation of delta as B dash and C dash. Okay, but it is very small, so we can neglect this. Okay. Next, number 3 assumption is shear deformation are neglected. Assumption 2, 3 are reasonable because distortion of rigid joint and structure due to axial forces and shears are really small compared to distortion due to flexor. Okay. This doesn't affect so much, so we can neglect this deformation. Okay. So how we will derive the derivation of slope deflection equation? With the equation which we are going to use in the numericals or to solve any rigid frame and continuous beam. Okay, so as you can see here, AB is a beam. Okay, some loading is given. There's a deflection, this delta, as you can see in the B point. So in step A, what we need to do, we need to find out the friction moment as we did in the moment distribution method also, MFAB and MFBA. So there are some formulas you need to remember. Okay, so step 2, what is the step 2? Just give me a second. Okay, in the step 2, we need to remember this halos that is given by 4 EI by L into theta A, and half of this is in the B point, and that is 2 EI by L into theta A. Similarly, if we consider this side first, then it will be 4 EI L by theta B, and this side half of this 2 EI by theta B. If we allow the settlement, if we allow the deformation in both the point, this is our friction moment MFB and MB, and if we allow a deformation theta A in this point, theta B will, so when we consider deformation in this point, then you see in the both equation theta A will come 4 EI by L into theta A and 2 EI L into theta B. Okay, when we allow deformation in this point, so see 4 EI by L into theta B, and half of this is 2 EI by L into theta B. We need to consider at the other point to balance the beam. and this equation is for settlement. If we require there are settlement delta for this on the both sides 6 ei by l square into delta, and this side also 6 ei by l square into delta. Just you need to remember these terms. Okay, so finally mfab is given by, we need to add this 4, this side, all these 4 we need to add mfab plus 4ei by l theta a plus 2ei by l theta b, this, and last is this 6ei l square into delta. Okay, so if we simplify this, you will get the equation like this. Similarly mfba, by adding all the term, if we add we will get this. Okay, same thing, just theta and theta b will be different. Here it is mfab, here it is mfba, here it is 2ei by l, same 2ei by l. Here is twice theta a, but here it is theta b, here it is theta b, but here it is twice theta b, and this is the same, twice minus 3 delta by l. Okay, we are considering the sign as per the moment, which we have considered as clockwise and anti-clockwise as in case of moment distribution method also, so we need to consider the same. The complete whole derivation is very long, that's why I'm not giving you, but I will send you the pics of that derivation, you can compare with that. But for this you need only remember these things only. Okay, these formulas is enough. Okay, there is an example given, as you can see here. Beam is given, the two span, as you can see. By using the slope deflection method, we need to find out all the datas, and finally we need to draw the Bmd and Sfd. Okay, for that what we need to do, as you can see here, first we need to find out the fix and moment for the span AB. So as you can know, WL by 8 is a point load given at the equal distance of the beam, so WL by 8 you can directly write. Similarly MFPA you can also find out. So in the next span BC, it is given UDL, so WL square by 12. You can find out both the things. I think up to this it's very simple, you can easily do. So after this only we need to use the slope deflection equation. Okay, excuse me. After this part only we need to use the slope deflection equation. I think there is not much time left. We will not able to finish this today, so it's better we can continue this in the next class. I think. What do you think? Can we continue today, or can we start in the next class this new market? Okay, fine. We will continue in the next class, the numerical, because the numerical is a little bit long, so we will not be able to finish today. So it's better we'll start in the next class. So till then, all of you will please do one thing. You go through the all the theory part, all the introduction part, and the derivation part, so that you can it's easy for you to understand when we solve the numerical. I'll send you the derivation also to you. All of you please go through that once, and we'll discuss the numerical in the next class. Okay. Okay. All of you please give me your attendance. Hopefully, the college will start from November, so that we will discuss this thing in the class also. But you be prepared, okay? Maybe your class will start from 1 November in the university.
Sir, the class will start from November 8th in the college.
I think maybe because there's some government notification is coming out. As per the notification, it is said that from November, the university and colleges will be reopened in Assam, okay?
Oh, okay, sir.
Don't know about the other state. I think Assam, as per the government, they are saying that from November 1st, it may be reopened. You'll come to know, okay?
Oh, okay, sir.
I think after Puja vacation, you will come to know because you have to come now.
Yeah.
You have to come. You have to stay in quarantine. Then you need to go through the test.
Mm.
Hopefully, after this also, we may get some class in the university before I leave
Yes, sir.
because
That's a good news then.
it's not good like this. Okay, just wait for 1 second. Is there anyone left to give you attendance? And is there someone who got disconnected due to network issue? Bumken Neurak is in the class. Bumken Neurak. Bumken. Okay then everyone, thank you. We will continue in the next class. Okay, then we will continue in the next class. All of you go through the introduction part once. Thank you all.